Welcome to Pramod Nainapalli YouTube channel. Today I am going to discuss third semester first unit topic. In that I am going to discuss in the first unit, that is structure of benzene. Structure of benzene. So structure of benzene, to discuss this, we will first discuss what is an historical background of this particular benzene. So what is this benzene? Where this has been discovered? So benzene was first discovered in the year 1825 by Michael Faraday. Michael Faraday. He isolated benzene in the oil. He isolated the benzene from the oil. So 1825, Michael Faraday isolated the benzene and he has explained that it contains equal carbon and hydrogens. But he has not said regarding any structure of benzene. To understand the structure of benzene, in the year 1865, the August Kekulé given the structure of benzene. He has given the molecular formula C6H6. He has given the molecular formula as C6H6, and he mentioned that the structure, theoretically, the structure of benzene contains 6 carbons and 6 hydrogens. How many carbons? 6 carbons and 6 hydrogens. They are called as benzene. But the theory of Kekulé was only the theoretical. It is not in a practical aspect. So, in the historical, the August Kekulé has contributed much of the theoretical aspect of benzene. So, benzene is having a carbon C6, hydrogen C6. How? 1, 2, 3, 4, 5, 6. 6 carbons are there. How many hydrogens are there? 1, 2, 3, 4, 5, 6. So the molecular formula of the benzene is C6H6. Now, when the question has been given, explain the structure of benzene, means the structure of benzene can be explained in 3 aspects. The first aspect is Kekulé's structure. Kekulé's structure. The first aspect of study is Kekulé structure. The second aspect is we are going to explain the chemical structure of benzene. Chemical structure of the benzene. And third aspect is the resonance structure. What is that? Resonance structure. Resonance structure. By this 3 particular concept, we can explain exact structure of benzene. Now let us discuss about how does actually these 3 points are very important. 3 concepts are important to explain the structure of benzene. Now let us see one by one concept to understand actual structure of benzene. First point is structure of Kekulé's structure. First one is Kekulé's structure. What is Kekulé's structure? What does the Kekulé said about the benzene? So benzene consisting of a hexagonal shape. What shape it contains? It contains an hexagonal. Hexagonal means 6 carbons are there. So they are hexagonal or hexagon. First point is to remember that benzene is hexagon. How many carbons are there benzene? To describe the benzene, he said that how many carbons are present means there are totally the carbons which are present, you know very well. There are 6 carbons which are present here. So okay, these 6 carbons which you can see that they are very important. Okay, so these 6 carbons are present here, and the 6 carbons are present. The second point is what it contains means it contains 6 carbon. It contains 6 carbons, and there is a bond between carbon and hydrogens. Yes, on every carbon if you see there is a bond between carbon and hydrogens. Carbon and hydrogens. So how many carbon and hydrogens bonds are there? So the bond 6 hydrogens are there, 6 carbons are there. So they are called as in conjugated double bonds. Inside the bond is called as a conjugated double bond. What is the meaning of conjugated double bond? The calculus said that there is a conjugated double bond. Conjugated double bond means alternative double bonds. Here single bond followed by double bond, single bond, double bond, single bond, double bond. So conjugated double bond means alternative double bonds. Alternative double bonds. Alternative double bonds. The bonds are alternative. They are not consecutive. They are not consecutive. Consecutive means they are not actually the continuous, but they are alternative. You can see in the structure I have shown you. Okay, so single bond is there, here double bond is there, single bond is there, double bond is there, single bond is there, double bond. On every bond there is a single bond and double bond structures are there. So this all aspects are only the theoretical. Calculus said that it is an hexagonal in shape and it is a planar in structure. The other point is they are planar. Okay, so planar means what type of hybridization it contains means it contains totally how many sigma bonds are there? How many sigma? 1, 2, 3, 4, 5, 6. How many sigma bonds are there? C single bond C are 6. How many carbon and hydrogens are there? That is also 6. How many pi bonds are there? These are sigma bonds. How many sigma bonds are there? Between carbon and carbon? 1, 2, 3, 4, 5, 6. Between carbon and hydrogen? 1, 2, 3, 4, 5, 6. Between the pi bonds, how many bonds are there? Pi bonds means double bonds. How many are there? 1, 2, 3. So pi bonds are 3. So they are planar in structure. When we tell that they are in the planar in structure, okay, their structure is planar and also they have the pi bonds, planar hexagonal in shape. What they are? They are planar. You know the meaning of planar, plane. There will be like in a plane which are hexagonal in shape. They have the 6 carbons and carbon and hydrogen bonded each other. So equal carbons, equal hydrogens are there. They are conjugated double bonds, which means there is an alternative double bonds. There is a 6 sigma bonds, C single bond C. How many are there? 6 are there. C single bond H, 6 are there. Double bonds, how many are there? 3 are there. So this is what the theoretical aspect the calculus explained. Now let us see the other concept. What is another concept we will come to know means the second concept is chemical structure. What it is? The second concept what you have to understand here is chemical structure. Chemical structure. So chemical structure. So what is a chemical structure? Now so far the theoretically calculus said it contains 6 carbon, 6 hydrogens. It contains 6 carbon-carbon bond, carbon-hydrogen bond 6. Pi bonds are conjugated. They are planar in structure, hexagonal in structure. These all are theoretical aspects. But practical aspects, what it is? Practical aspect actually, how we can explain this practical aspect? Now, to explain the practical aspects, certain things are very, very important. What are those things? In the practically, when they seen X-ray diffraction studies, you can find that the benzene is structure, 6 carbon, 6 hydrogen, alternative double bonds. Okay, they are double bonds are there. Okay, so you can find the bond angle. So bond angle is 120 degrees. Why they are 120 degrees means there is a carbon-carbon double bond. Carbon-carbon double bond and also carbon-carbon single bond. Carbon-carbon single bond. But carbon-carbon double bond is very important. So you know that in the first year you have studied double bonds will show the sp2 hybridization. What hybridization? They are in sp2 hybridization. What is the meaning of this sp2 hybridization? When carbon-carbon double bond are there, we generally tell it as, we call it as sp2 hybridization. Now carbon-carbon double bond or sp2 hybridization. So first, what is hybridization? You have to know. What is hybridization? Hybridization. What is this hybridization? Hybridization means one orbital combined with another orbital to give a new orbital. Then it is called as an hybridization. Now, how does the sigma bonds are formed? C sigma bond C. C sigma bond C are formed by the end-to-end overlap of SS orbital or end-to-end overlap of PP orbitals, SS orbital, end-to-end overlap of S orbital followed by P orbitals. So either SS orbital or PP orbital or SP orbitals, they will be overlapping end to end. That is called as an end to end overlap. But double bonds, they are formed by sideways or parallel overlap of P orbitals. So S orbitals are in spherical shape. What shape they are? They are in the spherical shape. P orbitals are dumbbell shape. So S orbital are in the spherical shape, P orbital are in the dumbbell shape. Now let us understand how does this sp2 hybridization, how the double bonds takes sp2 hybridization. Now to understand this, you have to know the electronic configuration of the carbon. So carbon generally, valency of carbon is 4. How it is 4 valency of carbon? What is the valency? Valency means the unpaired electrons present in the outermost orbital. What is that? 1s2. What is the electronic configuration? 1s2, 2s1, 2px1, 2py1, 2pz1. So these are unpaired electrons present in the outermost orbitals. So how many unpaired electrons are there? This is paired. Okay, this is not outermost orbital. This is an outermost orbital. How many are there? 4. Hence carbon can bond with 4 other atoms. Because they are unpaired, they will get paired. Now for single bond, C single bond C, sigma bonds, the hybridization is sp3 hybridization. The hybridization is sp3 hybridization. How means the valence of carbon is 4. 1s orbital will overlap with 3p orbitals. Unpaired 1s orbital is overlap with 3p orbital. That's why it is sp3 hybridization. They overlap to give a new hybrid orbitals. Okay, 1s orbital will overlap with 3p orbitals to give a new orbital, that is called as an sp3. C double bond C. Which hybridization? C double bond C. C double bond C is sp2 hybridization, because one of unpaired electrons are paired. One of unpaired electron is paired. Means in the p orbital, if you see one of them are paired, means you cancel one from this. Now how many are there? 1s is there, 2p's are there. Yes, 1s, 2p orbitals. 2p orbitals. 1p orbital are involved in the pi bond formation. 1p orbitals are involved in pi bond formation. So 1s and 2p orbitals. That's why it is called as sp2 hybridization. Now C triple bond C. Here you are having sigma bond, 1 sigma bond, 2 pi bonds. In previous case 1 sigma bond, 1 pi bond. But 2 pi bonds are there. Means 2 unpaired electrons are involved in the bonding, pi bond formation. Now how many are there? 1s orbital overlap with 1p orbital. That's why it is sp hybridization. So this is the hybridization of general to understand for you, okay, based upon the valency. But what is an hybridization of a this particular hybridization means? The hybridization practically I have seen that they are in the sp2 hybridization. So they are involved in the sp2 hybridization. Bond angle, when sp2 hybridization means the bond angle will be always 120 degrees. How much bond angle is? 120 degrees. So the chemical structure gives bond angle 120 degrees. And bond length, this is the first factor. Second factor is bond length. So what is a bond length? Bond length of all CC carbon or CC carbon, between carbon and carbon, all the bond length is the same. That is 1. This is an orbital picture of single bond, sigma bonds in the structure. I have written carbon-carbon is having single bond. Single bond means they are formed by either sideways overlap of pp orbital or sp orbital or ss orbital. I have denoted with pp orbital. pp orbital. So their bond is formed by the overlapping of pp orbitals, end to end, pp orbital, pp orbital, pp orbital, pp orbital, pp orbital. And between carbon and hydrogen, I have denoted with s and p orbitals. S and p orbitals means s is spherical, p is dumbbell shape. So dumbbell shape. So dumbbell shapes you can find here. So s and p, they are formed by the overlapping of s orbital and p orbital. S orbital and p orbital. End to end overlapping of s and p orbital. End to end overlapping of sigma bonds, p orbitals. Okay, p orbitals. They are all are sigma bond. Sigma bond means they are single bond. Single bond. So this is an orbital representation of single bond. Now when you come to the point of orbital picture of, so this is an orbital picture of carbon-carbon double bond. I told you in the earlier that carbon-carbon double bond are formed by the sideways overlapping or sideways or parallel overlapping of p orbitals. So this is a way of representation, parallel representation of this pi bond or pi electrons or electron cloud. So the electron clouds which are there, they are parallel. So they are parallel to each other. So pi bonds are formed by the overlapping of sideways overlapping of p orbitals. So this is what the chemical structure of the compound. The chemical structure, what you can represent is the representation of chemical structure. You can find that there is a pi electrons are there. That pi electrons are not placed in one particular place. It will be resonating. So what about that resonance? We will discuss now. So resonance, what is resonance? Resonance is defined as same structure written in a different forms which differ only in the movement of pi electrons or a pi bond. You can see here the ring is having here pi bond, here pi bond, here pi bond. Now this is moved here and this is moved here and this pi bond is moved here and you got a second structure. So both are benzene only. Both are benzene, but only there is a change in the movement of pi bond. That is called as a resonance. They will be available in the resonance form and they will delocalize throughout the ring. That's why it is in the ring form, delocalization of pi electrons. In general, we write the structure of benzene as, commonly we don't represent a double bond, we will keep ring. Because the ring indicates the delocalization of pi electrons. Delocalization of pi electrons throughout the carbons. That's why we write the ring. This is also structure of benzene. Okay, so benzene involves the movement of pi electrons. There is a conjugated double bond. What is that conjugated double bond? Conjugated double bond means alternative double bonds. They move towards each other, and as a result you get another structure, resonance structure. Both are benzene only, but only differ in the delocalization or movement of electrons or pi bond, that is called as a benzene. So finally it has been concluded by the Kekulé structure. Kekulé structure explained only the theoretical aspect. The second concept is a chemical structure. Chemical structure indicated that bond length is same for all the carbons. The bond angle is 120 degrees. sp2 hybridization. We have seen the orbital structure of the benzene. And finally, resonance structure, it is clearly indicated that the structure of benzene is having how many carbons? Having 6 carbons and having 6 hydrogens. That is, finally they have concluded that its the structure of the benzene is this one. It is in a structure of benzene. Finally concluded that the ring containing benzene ring or cyclo or hexagonal ring having conjugated double bonds, having hydrogens, they are in the planar structure, they are in the sp2 hybridization. Finally confirmed that the structure of the benzene is having a molecular formula C6H6. So this is how we will come to know about the structure of benzene. And to have the practical evidences, bond length or bond angle, they have been analyzed by using the X-ray diffraction studies. They have analyzed by using the mass spectroscopy, molecular weight. So mass spectroscopy is an instrument which will analyze the compound, what structure it contains, what molecular weight it is present. So with the help of mass spectroscopy, with the help of IR, finally they found that the structure of the benzene is this one. So Kekulé played a very important role in designing the structure of benzene. This is what the topic related to the structure of benzene. I conclude with this particular structure of benzene, that structure of benzene consisting of hexagonal in shape. They are in the sp2 hybridization. Their bond length is same. Their bond length is particularly 1.39 to 1.40 Armstrong, and their bond angle is 120 degrees centigrade. They are sp2 hybridization. They are having 6 carbons, 6 hydrogens. Finally, we can tell with all this point the structure of benzene consisting of C6 and H6 hydrogens. Hydrogen is 6 and carbon is